Alright, here are solutions for perfect problem 5 from Math 243. Basic idea here is making confidence intervals. So to study the distribution of vertical leaps for NBA players, I randomly called 64, that'll be important, that'll be N, NBA players, and had them jump for me. The sample data was left skewed. Turns out that's not really relevant. Most of them jumped pretty high. There were a few that could barely get off the ground, blah, blah, blah. That's why it's left skewed. With a mean of 25 inches, this is my sample mean here. So this is X bar. And a standard deviation of 10 inches. This is the standard deviation for my sample. So this is S. So using the above statistics, create 90, 95, and 99% confidence intervals for the average vertical leap of all NBA players. State the shape, the center, the spread, and sketch the picture for each of the three. Okay, so in the first one here, let's start with shape, center, spread. The shape of this distribution will be approximately normal because everything in this class is approximately normal. And you might disagree. You might say, no, it says up in here that it's left skewed. How's it approximately normal? It's approximately normal because we're talking about the shape of the sampling distribution, so we can apply the central limit theorem. And because n is greater than or equal to 30, the central limit theorem tells us that even if the parent distribution is not approximately normal, the sampling distribution is. The center of the sampling distribution, it's our point estimate. We'd like to use mu, but we don't know mu. We're setting up this confidence interval for mu. Mu is an unknown in this case. So our best guess at what mu is X bar. X bar given to us as 25 in this problem. Spread. So similarly, I wonder if I should write. No, I'm going to leave it like that. For the spread, we don't know sigma, but we do know S, the standard deviation for the sample. So that's our best guess at what sigma is. However, our spread won't be S, it'll be S over the square root of n, because we're talking about the spread of the sampling distribution. So S was 10, and n was 64. So this is what, 10 over 8, which is 1 1/4, it's 1.25. Shape, center, spread. Then what we can do is draw our picture. Pretty good. And what we want is, first we'll do a 90% confidence interval. So we want some points here and here that makes this area in here 90%. The middle should be 25. Our answers will be this number and this number. So you can come up with that a few different ways. You could use the inverse normal function on your calculator. You could say there's 5% area out here. So 0.05 with inverse norm will give you the answer. But there's an easier way to do it. If you hit stat and then go over to calc, and then go over to tests, you get a bunch of intervals if you scroll down. 7 says Z interval, 8 says T interval. There's a bunch of them if you keep scrolling down. The one we want is 8. We want a T interval. Why do we want a T interval? It's because we have S and not sigma here. So that means that the shape is approximately normal following the T distribution. I wonder if I should even write that here. Approximately normal because n is greater than or equal to 30. T distribution. Because sigma, it's a horrible sigma, is unknown. Sure, why not? I'm going to have you guys write this whole thing out this quarter. So T interval, it asked me a few things. It says, do you have the data itself? Do you have the list of the 64 players and how high they jumped? I don't. I just have statistics about it. Okay, it says, all right, well, what was X bar? X bar was given me in the problem as 25, right here. It says, what was S? Note that it's asking for S, not sigma, because it's a T interval. S was given to me in the problem as 10. Note, we don't want S over root n here. We tell it S, and we tell it n, and it figures out S over root n. So really what it's using is S over root n, but we don't calculate that. Let the calculator do it for you. Confidence level, we want a 90% confidence interval, so I'll put in 0.90. And if I go down here to calculate, what it'll do is give me my two endpoints. Thinking, there we go. 22.9 and 27.1. I guess I'm supposed to wait to draw my conclusions. I'm going to write my conclusions in here each time. So I am 90% sure that the true value of mu, so this is the population average of all NBA players. I don't know this thing, but I'm 90% sure that it's somewhere between 22.9 and 27.1. I'm 90% sure that the true value of mu lies between 22.9 inches and 27.1 inches. So that is everything. Now we just have to do that 2 more times. A little bit annoying, but okay. Shape, same as above. Center, turns out that is also same as above. Spread will be a little bit different. Spread is, oh no, it won't be different. My value of n is still the same. So it's going to be the exact same for all 3 of them. You know what? I'm going to save some time. I'm going to say this right here is the same. Then I'm going to go and draw my picture. My picture will look very similar. I'll draw a bad normal distribution. And then I'll create my confidence interval. I'll say 25 is in the middle. I'll say I want 95% as the area in the middle here. And then I'll do the same thing. I'll hit stat, tests, t-interval. Everything will be identical except this will be 0.95. Go down to calculate and it'll spit out my answer. Thinking, thinking. There it is, 22.5. 27.5. So I'm 95% sure. It's only 90% sure that it's between these 2 values, but I'm 95% sure that the true value, wish I could copy and paste, of mu lies between 22.5 inches and 27.5. So note this interval is a little bit wider. It's saying if I want to be 95% sure I get it right, I better make this a little bit wider. If I only need to be 90%, I can be a little bit more precise. I can have a smaller interval here. Alright, and the third one, all this stuff is the same also. The only thing that will change will be my picture and my conclusion. Jeez, it's ugly. I'm going to draw an approximately normal distribution. I'm going to put 25 in the middle. This time I want 99% of the area. And so the way I'll figure out these values, exact same. Stat, tests, t-interval. Give it the same statistics, 25, 10, 64. But this time I want 99% confidence. And my calculator will think about it for a minute and then eventually give me that my endpoints are 21.7 and 28.3. Note that these endpoints keep getting larger and larger. If I want to be more and more sure that mu is somewhere in here, I'm going to have to make these further out. So my conclusion, so I am 99% sure that the true value, I'll let you listen to the Warriors game in the background while I write, the true value of mu lies between 21.7 inches and 28.3 inches. Bam, and that is the end. There you go. Not the prettiest solutions, but those will work. So that's the end of perfect problem 5.